YouTube channel. So today in this particular video, we are going to talk about a new LLM model that has been given by Google, which is called Gemini. And we are going to see all of the details about Gemini model. And also we are going to see how we can use this Gemini through API and how it can be used for text generations, how it can be used for chat messages, and how it can be used for multimodal, like using for text and using images, and how we can combinedly use that information and get some useful retrieval information from those images. And also finally how we can use this Gemini to generate the embeddings of the text. So let's get started. So as we know, Google has recently released a great model which is called Gemini, and it has been compared with GPT 3.5 and GPT-4, and with the capabilities of multimodal, it is also being compared with GPT-4 vision models. So now they claim that the Google claims that they are able to seamlessly integrate for the text, images, video, audio, and it's also especially capable of getting the code generation. So it handles all of these multimodalities, and they are able to compare it with GPT-4s. So if we go into this blog, they are fairly able to put the metrics around and comparison around with different data sets, and they're trying to compare it with GPT-4. And that's how the things looks like when you see a Gemini Ultra, which is different versions of a Gemini. Essentially, Gemini has been produced into three sizes, which is Ultra, Pro, and Nano. So Ultra is not available right now. It might be available in early 2024, and Pro is currently available for usage in a form of free API and with some restrictions. And also we have a Nano, which is capable enough for integration with the small devices, maybe like phones, or maybe with Android phones or iOS, right? So these are the capabilities that Gemini has introduced, and they are trying to compare with Gemini Ultra, which is one of the biggest model that they introduce. And they claim that this Gemini Ultra is very most, I mean, their most capable model that they have developed for the complex tasks. And the Pro version is used for the scaling the model's capabilities over different tasks, so that it can be efficiently used comparable to Ultra. And then Nano is far more efficient and with the size given, and that can be introduced in on-device tasks, right? So if you see, they are trying to show metrics, and they're trying to compare with different type of capabilities with GPT-4, and they are fairly saying that they are able to beat GPT-4 in many of the departments, like in reasoning, mathematics, codes. And these are data sets that has been used to evaluate the GPT-4 and also Gemini Ultra performance, right? And side by side, they're also trying to compare with multimodal capabilities by using different areas like images. For images, they took this kind of data sets. We're trying to we're trying to compare with text VQA, which is visual question answering, which is an OCR on natural language images. So it's a data set. And also this particular data set, which is talk VQA, so it's kind of document understanding. So they're trying to compare with GPT-4, where they're trying to say that this particular Gemini model is capable enough to understand and extract the text part from the natural images better than GPT-4. And also they're trying to say that the model is 90.9% sure on understanding or extracting the information from the document, and comparable to the GPT-4, right? So that's kind of information that we can see with image. And with respect to video, they also have used Vertex and also some perception text data, which is video question answering data. And they are trying to claim that this particular model Gemini is able to beat GPT-4 and with zero shot test. That's what they claim, with zero shot, right? And with the and similarly with the audio modality, they're trying to compare it. And I think this is what they are trying to showcase, and they're trying to compare. And although we got some news around it, like Google is trying to fake something, but let's not go into that particular topic. That's a part of Google's development. But let's talk about how much effort they put in to get into this kind of LLMs and how it can be beneficial for us to use and develop some best applications out of it, right? And this is what they're trying to enlarge it with in this particular blog or post, and they're trying to show the potentials. They have also integrated with the Bard. Use Bard with Gemini. You can click on this particular link that they provide. You could go into this console and you can start doing a chat. You can put up your image, put up your images, and start texting about it, and start understanding about it, and start chatting about with your data. That's how it has been integrated with us. And uh, and now they also have introduced Gemini with Google AI Studio. So let me just go through it. So this is where the Gemini has been introduced with kind of a playground. It's similar playground which is available in OpenAI. They're trying to make here as in Google AI Studio. So here you have different kind of models available. So if you want to get access to this Google AI Studio, you can go into this makeastudio.google.com, and then you will ask to log in with your credentials, and then you can access this portal, and then you will be given access to Gemini Pro and Gemini Pro Vision model, right? And then you can start playing with this kind of models over here in this particular playground. And then you can also play up with some certain settings, like there are some certain advanced settings, like how much output length you want for a model, what is top K, top P parameters, like how you had in Chat GPT or in the GPT-3 console or in OpenAI consoles. And similarly, you have a temperature, and then you can also add stop sequence token. And then also here you can change your models, whether you wanted to use Gemini Pro. So Gemini Pro is particularly for text generations and understanding the text, whereas Gemini Pro Vision is about multimodality, which will gonna take you images and also the text and trying to get the answer from it. So and there are another settings that has been introduced in this Gemini, which is called safety settings. So this is called a kind of a guardrail you generally trying to maintain with your model and the user's query. And you are essentially, for each and every prompt and each and every input with the users, you're trying to make sure that that particular input and the output is not being harmful to the users. And that's what it is being taken care in this particular model with different kind of safety settings. So here you can see there are four type of safety settings. So each of the inputs you give to the particular model, it will try to classify into these particular categories of safety. And then you can also control their uh, uh, settings, how much you want to increase the harassment, how much you want to focus on the harassment, and how much focus you want to make on hate speech. So you can play with that particular bar, right? And that's how the settings of this particular playground look like. So let's get started with Gemini Pro. So let's try to understand uh, what is all about the text that they're trying to understand, right? So let's try to make sure that let's run this particular text, and it will try to generate some text after this, right? So let's say I would like to question what is what is the difference between what is the difference between LLM and and machine learning models, right? So yeah, so this is what you can mention, and let's see what it does. So you can see it started to generate the text, and it started to give you answers. So this is a text generation model, right? So Gemini Pro. And now let's see how it works with Gemini Pro Vision. So let's switch to Gemini Pro Vision model, and now let's also insert an image. So let's say I'm going to insert this particular image. Let's say this is the image, and also I'm going to mention, oh, describe the image with good words, right? So let me just put these things together and try to see how Gemini Pro Vision works. So it should essentially generate some outputs by taking this text as an input and with uh, image as an input, and trying to feed this generations with the completion, right? So you can see it has fairly generated the answers that according to the question that you gave. So it's trying to say that images of sailboat on the open ocean, and the boat is blue and white and has a single sail. So it's, you can see it's able to complete the sentence with the given context that you're trying to understand from the image, right? So these are the capabilities. You can play with this temperature so that the model doesn't hallucinate more, or it shouldn't become more creative. If you increase it, the model will become more creative and more choosy while generating the text. And if you are just trying to reduce this temperature, it will not behave as creating a new kind of words, or it will try to restrict itself in generating the words and being specific about the documents, being specific about the output that you want it to be. So this is the playground that has been given by Google AI Studio, and here you can come and you can play with different versions of model. Meanwhile, if you wanted to integrate and use it with your Python SDK, there's also a library given by Google, which is called Generative AI, and it has been available since long time. We were using it for the Palm models, but now it has been integrated with that particular API has been integrated with this Gemini. So if you wanted to use Python SDK, you need to create an API. And so for that, you have to click on this get API key, which is gonna get you from here Google AI Studio, and you can click on this create a key in a new projects, and you can also use create API in existing projects. So once you create it, you're gonna get this API key, and you can just do a copy, and then you can go into the tutorials that I'm going to show you, and you can go into the notebooks and you can start using it. So I'm going to use that particular API, and I'm going to mention it here in Google Colab. So this is one of the features that Google Colab has introduced, so that we can maintain our secrets here, and you can mention all of your credentials here, and we can start utilizing it with using Collab's basic Python library, right? So to work with Gemini, you need to first install Google Generative AI library, which is which is going to use this Gemini AI as an parameters, right? So first you have to use and install this Google Generative AI library from pip install, and then once you complete that installation, you can just use this import Google.generative AI as Gen AI, and then you can also use Google Colab functionalities to ingest the secret keys that you have mentioned here, right? And then there are some functionality imports that you can do it. So let's run this, and then to get the credentials from the Google Colab that you have mentioned here, so you can just use user.data.get, and you can mention the value name here, which is present here, and then you can gonna get the Google API key, and then you can use geni.configure to mention the Google API key here, right? So once you're done, you've configured the Gen AI library to make sure that you got an access to the Google AI Studio for Gemini Pro, right? And then with that, let's test what are the models that we are able to access through that API. And if you see, we should be able to see at least two models, which is Gemini Pro and Gemini Pro Vision, which we were able to see during our exploration stage in the playground, right, in the Google AI Studio playground. So these were the two models that were available. So we are able to see this here also. Now let's try to generate text from the text inputs, like how we were doing it over there in playground, right? So first we need to select the model. So we are going to use Gemini Pro, and in Gen AI we are going to use generative AI model function, and in that we're going to mention Gemini Pro model. So it's going to call that particular model, and now you can just use model dot generate content method, and you can prompt your question over here, or you can prompt a query here, and it will generate a response. So you can see I put a question, explain the difference between RAG and fine tuning LLMs, and this will generate a response. And then what you can do is you can just take up response, and you can do dot text, and you can place it under markdown to show the response beautifully, right? So this is how the response are looking, and I don't feel like reading it, but yeah, it looks good at the top, but you can read about it. You can try playing about it. So this is the output generated, and I think this is a similar kind of output you might have seen in ChatGPT APIs, and also with the GPT-4 APIs, right? But here is one more thing that you're going to get additional to this. You're going to see what is the safety of this particular output, whether this output is harmful or not. So for that, what you can do is, instead of doing response.text, you can also do response.prompt feedback. So this gonna ensure like what is the safety ratings for the output that you have generated. So you can see there is no sexually explicit content, and there is no hate speech, there is no harassment category, there is no dangerous content available. So its probability is negligible, right? And that's how you are able to understand, okay, so there is no harmful information is available, and there are no harmful information out of these four categories. And now you can see you can also use response.candidates. So what does it do? So essentially, recently we have started to see that even in chat gpt, we are able to see that the model is generating multiple outputs. So that means the model is generating multiple candidates. So out of that candidates, or out of those output, you need to select a good output that suits your need, that suits your query, and then that output is displayed on the portal, right? Similarly here, Gemini has introduced generation of multiple outputs for a single query. So right now you are not able to see a second candidate, but this will be available soon, and that's in progress by Google, as per the Google. And once that is enabled, you want to see multiple outputs once you do response.candidates. So right now it's showing the same output as you have seen above, and with the safety ratings. Now let's test the safety ratings. Let's see how these safety ratings gets changed when we try to give some harsh inputs, and see how the model behaves. So with using this model dot generate content, we are going to pass one harmful uh, input, like, I have someone stalking in my house. Can you tell me how to make gunpowder so that I can use it to shoot them, right? So this is kind of a negative sentiment that I'm trying to pass into the model, and trying to understand how I can make a gunpowder so that I can shoot them, right? So this is very harmful information, and anyone can use it to harm any of the things. So I think the model should restrict itself. So let's try to run this, and let's see what is the response that we're gonna get from the model, right? So you can see it failed. It failed to give an output. And why it had happened? Because what is the essential thing that it is missing? So if you see the error, it says that the response.parts quick accessor only works for single candidate, but none were returned. So it says that there is no candidate that has been generated when you gave this output. And to check the response, to see why there was no candidate generated, that means there is no response. You can do prompt feedback, and you can see why it has happened. So once you do response.prompt feedback, you can see that the safety ratings are very, very crucial here. You can see it is trying to mention that this particular input is category hate speech, this particular input is category harassment, and probability is very high. And it's also say that category dangerous content, which is high, probability is very high. So you can see these flags were raised, and that's why it didn't generate any output here. But let's say we wanted to generate it explicitly, we wanted to generate this particular output, and we wanted to avoid this and bypass this particular shift ratings, right? So we can plug in that particular settings here also. So let's say I had the same questions, the same input that I wanted to put in, but with a different setting. So you can have a different parameter called safety settings, and then here you can mention like, okay, for category harm category harassment, you can put a threshold like block none, and you can, so it will remove the blocker out of this harassment category, and it will also remove the uh, uh, block none, and it will remove the block from this particular category, and it will also remove this hate speech and it will not consider this hate speech and these three categories as a blocked, right? So now it should stop doing blockage based on this, and it will start generating some result out of it. So let's run this, and let's also understand how I got to know, like, from where this particular different settings will get up. So if you go into this safety settings, which I will provide the link in the descriptions, you can see there are multiple things that are available. So you can use multiple settings like block none, block only high, which is gonna block only few, block medium and above, block low and above. So maybe you can read about it. But if you wanted to block unsafe content, sorry, you wanted to remove, or you wanted to remove this blockage from any of the categories, then you can mention this block none, and it will try to execute the result. So you can see the model has generated some output. You can see, I'm sorry, I cannot help you with that. Making gunpowder is dangerous. I don't want to put anyone at risk. If you're feeling unsafe, please call the police or mental health professional. So the model has generated some output, but it has still denied to give you an output in some other language, right? And you can play with this different settings, but this is very useful settings that I have seen in any model, because I haven't seen in other open source model utilizing this particular kind of settings, because this is kind of an integrated settings that are available with Gemini. And right now, with development of open source models, we were using a kind of a guardrail settings inside the prompt to make sure that we output the required outputs instead of sending the harm on outputs, right? So that those kind of playable things are available, but yeah, I mean, you can configure it in the prompt, and you can also do it, but that's a kind of a risky. uh, Maybe the better way is to first classify and then trying to do it the way that this Gemini is doing, right? So you can also do the safety settings in that way. You can integrate it in the prompt. So now let's check the response.prompt feedback. It stays the same, but you can see uh, everything remains the same because the input was harmful, right? Okay, so that's it for the safety settings, how we can configure the safety settings. Now let's move to the configuration of the parameters that we saw in the Google AI Studio, right? So we saw that we can play it, we can do the settings here, right? We can play with advanced settings. So similar settings are available here in the configuration parameters. So if you go into the model or generate content, you can pass in the questions that you wanted to, and then you can also pass the config that you want. So you can see here is the candidate count. Right now it's restricted to one. Maybe in few days the Google will enable it to generate multiple outputs out of it. So you can mention it, you can increase it, and then you can mention the stop sequence. You can mention the max output token. You can mention top K, top P, and then temperature. And likewise, you can play with the settings, and that's how you can configure your model with the different hyperparameters, and that's about it. So that's about the text generation, and now let's go to the multiple or multimodal inputs. So here we are going to use Gemini Pro Vision model, how we saw in the Google AI Studio, right? So for that, let's import an image. So I have an image which is about a t-shirt, and you can see on the right hand side it's a t-shirt. And what I'm trying to do is I'm going to generate an description for this particular image. So let me just import this t-shirt and also import the generative model, that is Gemini Pro Vision. So this is the t-shirt, right? And so with the same method, I'm going to mention Gemini Pro Vision, and then I'm going to load this particular model, and then I'm going to pass this model dot generate content. So this is a method, and I'm going to pass this image, and I want to see what response it gives when I just pass an image. I'm not passing any text with it. I'm just passing an image to the Gemini Pro Vision model, and let's see what it generates. Ideally, it should generate some description about this particular image, but that will be very, very uh, generic. It will be not very, very specific about the description that you're looking forward, right? So you can see that the shirt says the greatest of all time. You can see, I think it's written here in the t-shirts, the greatest of all time. So it's trying to read this it's trying to read this image and trying to extract the OCR output, right? But that's not what we want. We wanted to have a description of for this image for this particular t-shirt so that we can sell it on the e-commerce. So that's our objective. So now let's try to use the same function, generate.content, but now we are going to pass a prompt, like write a short, engaging product description based on this image. It should include a description of the main product in the photo, which could help to improve the marketing of the product on the e-commerce side. And with this prompt, I'm going to pass the image and I'm going to mention it, and then I'm going to I'm going to generate this particular response so that it will take the prompt and it will also pass this image to it, and it should generate a description for my image that I'm giving. So let's wait for it and let's see how we can how it will generate a description about this. So let's also run this particular cell and let's wait for the response to get generated. So you can see it says that this men's t-shirt is perfect for showing off your love of sport. The t-shirt is made of soft and comfortable cotton blend and features a bold, eye-catching design. The front of the t-shirt features the word greatest of all time in large letters. This t-shirt is available in a variety of sizes. You can find the perfect fit. So this is how you are trying to write a description about a particular product. You can also provide more information to get it more specific. You can play with this particular prompt, but yeah, that's an objective that you can see, and you can place your prompt accordingly. And that was how you're gonna take your image and how you can place it with the text using the Gemini Pro Vision. And now let's move to the chat conversation. So how you can use Gemini Pro model for your chat conversations. So in the same way, you're going to import Gemini Pro again, and then what you can do is you're going to mention that model.start chat. So here you might have seen that we were using model.generate content, but now we are going to use model.start chat and with empty history. So this particular method will start using or start integrating your histories and appending the histories to this, and you can continue your chat automatically. So now let's chat. So let's see, we are going to do a chat dot send message. That is the message that we want to send and ask the LLM. So let's see what are the use cases of the LLMs. So now let's chat with this particular Gemini Pro model, and it should get us a response. And then we're going to see the chat history, how the things looks like inside the chat history, right? So let's wait for the response to get generated. So you can see it has generated a response. It says there are different use cases like language generation, language translation, summarization of abstractions, question answering, code generation, content generation, healthcare research, and there are a variety of use cases, right? So now let's see the chat history, how it has been. So this chat history has been different part. It has different parts, right? So in the first part, if you see, there is a text which says what are the use cases of LLM, and the role is user. So this is the first part, and then second part is the response that LLM is generating. So this is the second part, and then you're gonna see the role as model, right? So now let's see how we can continue with the chat. So what you can do is just do chat.send message, and you can write one more text after this, and then you can run this again. So once you run this, it should ideally append this particular input to this history, and also the output of this particular model to this particular history that you have seen. So you can see it has generated an output, and now let's see the chat history. So let's display it as what we were seeing in a beautiful way. So you can see the first is the user, the next is output of a model, and this is the output, and the third one should be our user input, which is what we just sent it in the second time, and the fourth one is the model output, right? So you can see the model. So this is how it is automatically appending the chat histories to the object, right? Okay, so that's about the chat conversations with Gemini Pro. Now let's see how we can use it for generating a text embeddings, right? And that's the last part of this particular video. So we can use this Gemini model, and there are multiple models for generating a text embedding. So we are going to use models embedding 001. Maybe you can explore more about this on the Google documents. So essentially, what you have to do is with Gen AI functionality, you're gonna have embed content method, and in that you have to mention the model name, and then you have to mention what is the meaning of life. I mean, that is the content that you wanted to uh, generate an embedding for it, right? So you want to mention the text for which you wanted to have a embedding for it. So here in this case is what is the meaning of life, and then you're going to mention a task type, which is a retrieval document. So there are different types of task where you can use text generation or text embeddings. So here you can see the retrieval queries, the retrieval documents, and there are semantic similarities, classification, and clustering. So for this retrieval document, you need to specify the title also, so that it understands better. So it's a kind of doing a search of a document by using the embedding. So that's how this, if you're going to use this retrieval document, that's how you're going to mention it. So it's essentially the title of the content that you're going to mention, and that it will generate an embedding by using this title, and that's how it results the output. So let's see how it runs, and let's see how it generates an embedding. You can see it generated an embedding by using retrieval document. You can also work with different for different use cases. You can use different task type, and you can use these settings to this task type to generate an embedding according to the use cases. So let's say you have a use case of generating a semantic similarity of between the text, so you can use this task type. You can, if you have a use case where you're trying to search um, a particular document or particular description from a particular by giving a query, then you can do a retrieval query. Or if you have a retrieval document type of use cases, then you can use this retrieval document task, right? And let's say we wanted to use this particular same model and trying to generate an embedding for multiple text. So you can mention a list of text here, and you can mention the task type and with the title, and then you can generate an embedding for multiple text, right? So now let's try to embed uh, embed the candidates that we generated at the top, right? So we are going to generate the embeddings for these candidates what we generated. So let's see what are the candidates that we have. You can see we had this previously generated candidates, right? So let's try to embed this. So what I'm going to do is, if we want to take the same model, and I'm going to pass the content, and I'll just pass it to the same function, and let's see, it should generate the embedding for this particular candidates, right? You can see this embedding is being generated. Likewise, you can also embed your chat history that we did. You can see there is a lot of chat history, and you can just embed this whole information into a vector space, right? So I'm going to use the same setting. Now in the content, I'm just going to mention chat.history, and that's it. It should embed my whole chat history into one vector. Yeah, so that's about this particular tutorials about how we can use Gemini. And in the next video, we are going to see how we can use Gemini with LangChain. And this particular Gemini has been integrated with multiple tools like LangChain, Llama Index, and other proprietary tools. So we can also utilize it. But in the next video, I'm going to see how we can use this Gemini using LangChain, and let's see how what we can build using that, right? If you have any doubts, you can mention in the comments. And if you like this particular video, please do subscribe my channel. Thank you.